Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject Network Analysis and Control Systems. I have already uploaded Module 1 to Module 4 topics in my channel. If you have missed out, please do watch. And I have already completed Module 1, Module 5, first chapter, second chapter and third chapter. And now in the fourth chapter, NYQUIST plot, we have already seen one topic. Today we will learn a new topic. The new topic is NYQUIST Stability Criterion. Principle of argument we have seen in the last video. In this video, I am going to cover NYQUIST Stability Criterion. NYQUIST Stability Criterion. Consider the single loop feedback system shown in figure 8.6. This is a single loop feedback system. You know it is a feedback system. The characteristic equation is what? Q of S is equals to 1 plus G of S into H of S is equals to 0. You can write. Right? You know the characteristic equation you can write from the closed loop system, feedback loop system. The standard pole 0 form of G of S into H of S is, you know what is, K into the open loop gain K into S plus Z1, S plus Z2, that is zeros on the numerator and poles on the denominator, S plus P1, S plus P2, S plus Pn. So m is less than or equals to n. Why? Because the 0 should be less than or equals to poles. Okay, 0 should be less than or equals to poles. So Q of S is equals to 1 plus G of S into H of S. You will write this. Then if you take LCM, what you will get? All the poles plus K into zeros by poles. So what you can do here is S plus Z1 dash, S plus Z2 dash, so on into S plus Zn dash. You can write in this way. Okay. By adding these two, you can write this whole numerator, you can modify to like this. Zeros by poles. The dash represents what? S plus Z1 dash, S plus Z2 dash, so on, S plus N dash. You remember this. Again it is converted to N dash. Okay, from equation 8.2 we observe that the zeros of Q of S at minus Z1, minus Z2 dash, minus Zn dash are the roots of the characteristic equation, and the poles of the Q of S are minus P1, P2, Pn. The Z1, Z2, Zn are what? Roots of the characteristic equation. P1, P2 are what? Poles of the characteristic equation. Z1, Z2 are zeros, which are the roots, and poles are the same as open loop poles of the system. For system to be stable, to make the system stable, the roots of the characteristic equation and hence the zeros of the Q of S must lie in the left half of the S plane. This we know in the root criterion also, that the roots, zeros, must lie away left half of the S plane to make the system stable. Even if some of the open loop poles lie in the right half of the S plane, all zeros of the Q of S, that is the closed loop poles, may lie in the left half of the S plane. This means that an open loop unstable system may lead to closed loop stable operation. The open loop unstable system may lead to what? Closed loop stable operation. See, this is a NYQUIST counter for this feedback system. Okay. In order to investigate the presence of any zeros of Q of S is equals to 1 plus G of S into H of S in the right half of the S plane, let us choose a counter which completely encloses the right half of the S plane. Such a counter, see, this is the right half of the S plane. It is enclosing the right half of the S plane. The points are on the complex axis also and on the S plane also. So it is directed towards what? Clockwise, and comprises of an infinite line segment C1 along the j omega axis and an arc along the C2 of an infinite radius. Okay, along C1 S is equals to what? J omega, varying from minus infinity to plus infinity, and along C2 S is equals to what? R tends to infinity e power j phi, with phi varying from plus pi by 2 to 0, plus pi by 2 to 0, plus pi by 2 to 0 to minus pi by 2, minus pi by 2. Means the Nyquist counter so defined encloses all the right half of the S-plane zeros and poles of the Q of S is equals to 1 plus G of S into H of S. It will enclose all the right half of the S-plane. Let there be zeros and poles in the right half of the S-plane. As S moves along the Nyquist counter, in the S-plane, a closed counter is traversed in the Q of S plane, which encloses what? The poles minus zeros. Poles minus zeros. So times in the counterclockwise direction. You know that if there are poles and zeros, what you will do? Based on the principle of argument, n is equals to poles minus zeros you will do. Okay. For the system to be stable, there should be no zeros of Q of S in the right half of the S plane. For the system to be stable, what we need? The zero should be not on the right half of the S plane. That is z is equals to 0. This condition is met if n is equals to p. For the systems to be stable, the zero should be only on the left half of the S plane, that is this side. If the zeros are on the right half of the S plane, the system is not stable. So to make the system stable, you need to make S is equals to 0. That is, for a closed loop systems to be stable, the number of counterclockwise encirclements of the origin of Q of S plane by the counter should equal the number of right half S plane poles of Q of S, which are poles of the open loop transfer function. For open loop stable systems, that is P is equals to 0, the closed loop system is stable if n is equals to P is equals to 0. Okay. For open loop stable systems, the closed loop system is stable when n and P are equals to 0, which means the net encirclements of the origin of Q of S plane by the counter should be 0. When these both are 0, the encirclements is also 0. It is easily observed that G of S into H of S, 1 plus G of S into H of S minus 1. If you do, again you will get G of S into H of S only. You are adding and minusing 1. If therefore follows that the counter of the open loop transfer function G of S into H of S corresponding to the Nyquist counter in the S plane is same as the counter 1 plus G of S into H of S drawn from the point minus 1 plus J0. Thus, encirclement of the origin by the counter is equivalent to the encirclement of the point minus 1 plus J0 by counter as shown in figure 8.7. This is how the counter is drawn for the point minus 1 plus J0. Okay. Which means that RQ and this the counter of 1 plus G of S into H of S, and this is what same. What is that telling? The NYQUIST stability criterion may now be stated as follows. How it is stated, we will see now. If the counter of the open loop transfer function G of S into H of S corresponding to the NYQUIST counter in the S plane encircles the point minus 1 plus J0 in the counterclockwise direction as many times as the number of right half S plane poles G of S into H of S, the closed system stable is what? System is what? Stable. In the commonly occurring case of open loop stable system, the closed loop system is stable if the counter of G of S into H of S does not encircle the minus 1 plus J0 point. That is, the net encirclement is what? 0. The mapping of the NYQUIST counter into the counter is carried out as follows. The mapping of imaginary axis carried out by the substitution of S is equals to J omega in G of S into H of S. This converts the mapping function into a frequency function, right? S is equals to J omega. Even in the Bode plot, we did the same. In physical systems, M is less than or equals to what? N. 0 should be less than or equals to poles. Limit S tends to R e power J5. R tends to infinity. G of S into H of S is equals to what? A real constant. It is 0 if M is less than N. Thus, the infinite arc of the NYQUIST counter maps into a point on the real axis. The complete counter is thus the polar plot of g of j omega with omega varying from minus infinity to infinity. This is usually called NYQUIST plot or locus of g of s into h of s. The NYQUIST plot is symmetrically about the real axis, since the g star of j omega and h star of j omega is what? G of minus j omega, h of minus j omega. Nothing but complex conjugate of this complex conjugate. The star indicates what? Complex conjugate. Open loop poles on the j omega axis. If the open loop transfer function g of s into h of s and therefore the characteristic polynomial 1 plus g of s into h of s has any poles on the j omega axis, the NYQUIST counter defined earlier, figure 8.6b, cannot be used as such, since the S-plane counter should not pass through a singularity of the 1 plus g of s into h of s. To investigate stability in such cases, the NYQUIST counter must be modified. So to bypass any j omega axis poles, we need to bypass to modify the NYQUIST counter. So this is achieved by indenting the NYQUIST counter around the j omega poles along a semicircle of radius, some radius, which is tends to 0 as shown in figure. Here if you see, all the NYQUIST counter entered for j omega axis open loop poles are on the right half of the S plane, okay, in the form of semicircles. Draw the NYQUISTic plot and comment on the stability of system represented by this. This is the problem where you can understand more clearly. Then you'll understand the theory what I told previously. The open loop sinusoidal transfer function is given as what? In the place of s, you will write g of j omega, h of j omega, k by 1 plus j omega t1 into 1 plus j omega t2. Rationalizing it. Rationalizing what? Means what? If they both are plus in between. So you will minus, you will add in numerator and denominator this 1 minus j omega t1, 1 minus j omega t2, again 1 minus j omega t2 and 1 minus j omega t1. Nothing but we are multiplying and dividing 1 minus j omega t1 and 1 minus j omega t2 on the numerator and denominator. If you see, if you multiply this equation with this, you will get this only. Rationalizing means that in numerator the complex conjugate will be there, no? If it is plus, you will make minus in between and apply for numerator and denominator. Then if you multiply inside and simplify, you are going to get till here. Along the segment C1 of the NYQUIST counter on the j omega axis, S varies from where? Minus j infinity to plus j infinity, right? From the counter what we have seen. At omega is equals to minus infinity, what happens? You just put in the place of omega minus infinity, what you will get finally? You will get minus 0 plus j0. When you substitute omega is equals to 0 minus, then you will get k plus j0. Then when you apply omega is equals to 0 plus, you will get k minus j0. When you put omega is equals to plus infinity, then you will get minus 0 minus j0. So you got some points for each omega. So we get 4 points to draw an approximate NYQUIST plot. The infinite semicircular arc of the NYQUIST counter segment C2 of the figure 8.8a is mapped like this. See, j0 means here, j0 plus is 0 here, j infinity and minus j infinity is here, and you can map C1 and C2 in this way. Okay, and this is, there is that r into e power j5, r is tends to infinity. Okay, along the semicircular arc, you have what? S is equals to this, where phi varies from pi by 2 to pi by 2 through 0 degree to minus pi by 2. See, pi by 2 to 0 degree and minus pi by 2 again. Therefore, g of s into h of s is equals to what? limit r tends to infinity k by 1 plus. In the place of r, you can substitute re into j phi, right? In the question, whatever is given, just substitute, and limit r tends to infinity, phi tends to pi by 2 to minus pi by 2. So, if you substitute that, you will get what? K by r square e power j2 phi t1 t2, okay, is equals to 0 into e power minus j2 phi. So 0 at an angle of minus 2 phi. Angle what you have? Minus 2 phi. So the magnitude is 0. The magnitude is 0 and the phase varies from minus 2 to pi by 2 to minus 2 into pi by 2. Why? Phi is already given as pi by 2. So minus 2 into pi by 2, minus 2 into minus pi by 2, from minus 180 degree, nothing but, so the 180 degree to plus 180 degree. So the infinite semicircular arc mapped onto a point at the origin joining the omega equals to plus infinity minus infinity points in the Q of S plane. Okay. The point of intersection of the Nyquist plot with the imaginary axis is obtained by equating real part of g omega into h of j omega to 0. The real part is what? This is the real part equation. What you got is equals to 0. You should do. Then you will get 1 minus omega square t1 t2 is equals to 0. So you will get omega as what? 1 by root of t1 t2. So the value of g of j omega, h of j omega at that point of intersection is obtained by substituting this value. If you substitute this value in the imaginary part, whatever you have, okay, the imaginary part equation what you got is this. So in the place, what you will do, placing the omega in this equation, what you will get? You will get finally by substituting and simplifying, you will get this value. Then based on the above information, an approximate Nyquist plot is drawn as shown in figure 8.b. Nyquist plot is drawn. From figure 8.8b, it can be observed that the Nyquist plot of g of j omega, h of j omega does not encircle the minus 1 plus 0. Minus 1, it is not encircling this minus 1 plus j0 point of Q of S plane for any positive values of k, t1 and t2. For any values of t1, t2, k value is positive. Therefore, the system is stable for all positive values of k, t1 and t2. So, the system is what? Stable. Okay. See, here if you see, minus 0 plus j0, minus 0, minus j0 is present, and this is what the omega value where it is touching, and this is the value what you got for g of j omega into h of j omega. As it is not touching minus 1 plus j0, what it means is that omega is increasing, and even though the positive values of k, t1, t2, therefore the system is stable for all positive values of k, t1 and t2. Second question. Draw the Nyquist plot and assess the stability of closed loop system whose open loop transfer function is this. The open loop transfer function is this, and if you see here from the transfer function of the open loop system, we observe there is one pole in the right half of the S-plane. See, one pole is on the right half of the S-plane. Which pole? It is S is equals to plus 1. That is this, S is equals to plus 1. So the open loop system is unstable only. P is equals to 1. So, for the closed loop system to be stable, the Nyquist plot of g of s into h of s must encircle minus 1 plus 0 point of q of s plane once in the counterclockwise direction. See, as the system is unstable, so for the closed loop system to be stable, to make it stable, the Nyquist plot of g of s into h of s must encircle what? Minus 1 plus j0 point of q of s plane once in the counterclockwise direction. How to do that? G of s into h of s in sinusoidal form is, in the place of s, you substitute what? J omega. So substitute j omega and simplify. You are going to get the final like this. You are going to get finally like this. Then along the segment of C1, what you should do? Again you should put minus infinity, 0 minus, 0 plus and plus infinity. You will get some values. Same like previously. In the place of k, you will get 4. That's it, the difference. So we get 4 points to draw on an approximate Nyquistic plot. Along the semicircular arc of Nyquist counter, this is the thing, phi varying from plus 90 degree through 0 to minus 90 degree. So pi by 2 is also same and 90 degrees also same. So don't get confused. So then g of s into h of s is what? If you substitute this, you will get what? 0 into e power minus j phi. See, limit tends to what? R tends to infinity. When r is tends to infinity, what you will get? You will be left with 1 by, if you simplify this, you finally get what? 0 into e power minus j phi. That is the origin of the g of s into h of s plane. The g of s into h of s locus thus turns at the origin with 0 radius from minus 90 degree through 0 to plus 90 degree. Based on the above information, an approximate Nyquist plot is drawn as shown in figure 8.9b. This is the same diagram what we will draw for all the questions, but the diagram for this, the Nyquist plot will change. That is, it indicates that minus 1 plus j0 point is encircled by this locus once in the counterclockwise direction. So this closed loop system is stable. To make it stable, what we told that minus 1 plus j0 it should encircle. So if you see here, this is 4. This length is 4 and it is encircling once from the minus 1 plus j0 from 0 to, see here it is 0 plus j0 and this is minus 0 plus j0 and this is minus 4 minus j0 minus 4 plus j0 is over this side. If you mark this, this becomes what? The counter, Nyquist plot or the Nyquist counter. Third question, draw the Nyquist plot and assess the stability of the closed loop system whose open loop g of s into h of s is equals to what? K by s into 2s plus 1. Transfer function is what? The given open loop system has a pole at the origin. S is equals to 0. So Nyquist counter must therefore be intended to bypass the origin as shown in figure 8.11a. It should bypass the origin like this. It should bypass the origin like this. See, if the pole is at the origin, s is equals to 0. What we've learned that it should bypass the origin in the theory. We should bypass the origin. That is what we are applying here. This should bypass the origin in this way. See, the line will bypass the origin in this way. You just see the line what I am drawing with red color. See, it should go like this and like this and it bypasses. It will not go to the 0. Why? Because it is at the 0. The mapping of the Nyquist counter is carried out as follows. The open loop transfer function in sinusoidal form is what? G of j omega into h of j omega is equals to, if you simplify, you are going to get the final values like this. Again, what you will do? Again put omega equals to minus infinity, 0 minus 0 plus and plus infinity, you will get some values. Okay, we got 4 points. From those 4 points, what you can do, the infinitely small semicircular indent around the pole at the origin 8.11a represented by what? S is equals to e power j phi j theta, that is theta varying from minus pi by 2, that is nothing but 90 degree through 0 to plus 90 degree, maps into what? Limit some variable it is tends to 0. What you will get? K by e power j theta 2 into e power j theta plus 1. So limit k by e power j theta. If you substitute this, finally you will get infinity into e power minus j theta. So minus theta is varying from where? Plus 90 degree to minus 90 degree. Thus, the infinite semicircle indent around the origin of the S plane maps into semicircular arc radius plane extend from plus 90 degree through 0 to minus 90 degree. The infinite semicircular arc of the Nyquist counter of figure 8.11a represented is what? This, where phi varies from plus 90 degree through 0 to minus 90 degree is mapped to what? So if you take in this way, in the place of S, you will substitute what? R into e power j phi, R into e power j phi. If you substitute, you will finally get what? 0 into e power j 2 phi. In the place of R, if you substitute infinity, you will get this. Then that is the origin of the g of s into h of s. So the g of s into h of s locus thus turns at the origin with 0 radius from minus 80 degree through 0 to minus 80 degree. Just it will turn like this. Okay. So based on the above information, approximate Nyquistic plot is drawn here. See, Nyquistic plot, how it will look is from 0 like this it will go and like this. How means we got values what at omega equals to minus at omega equals to minus infinity it is this, and here it is this. You have done first point. The second point what you got is minus 2 2k plus j infinity. So you will go in this way, okay, and in this way, like that. You should draw the Nyquist plot. Okay. Fourth question. Draw the Nyquist plot and assess the stability of the closed loop system whose open loop transfer function is this. The given open loop system has a double pole at the origin. Where S square means what? 2 times poles. 2 origins are there. The Nyquist counter is therefore intended to bypass the origin. It should bypass the origin as it is at the origin. So the mapping of the Nyquist counter is obtained like this. See, it should bypass the origin, same way what we have done for the previous question. And if you substitute in the place of s j omega, and if you simplify, you will get like this. Again, what we should do for the Nyquist counter to draw, we should take the values of minus infinity, 0 minus, 0 plus, and plus infinity. You will get some different values here, as all are infinity. All are minus infinity plus j infinity, minus infinity minus j infinity, and minus 0 minus j 0, minus 0 plus j 0. You are going to get in this way when you substitute omega equals to minus infinity and all. So the 4 points you got. For those 4 points, you can directly draw in this way. How it is, we will see. So we get 4 points to draw an approximate Nyquist plot. The infinite semicircular arc of the Nyquist counter segment C2 figure 8.12a represented by S is equals to what? E power j theta, where theta is varies from minus 90 to through 0 to plus 90, and if you substitute limit limit that variable tends to 0, and if you substitute and if you see, you will get infinity into e power minus 2 theta. So infinity into angle 180 degree to 0 to minus 180 degree, same like the previous, plus 180 through 0 to minus 180 degree as shown in figure. So the infinite semicircle of the Nyquist counter of figure 8.12a represented by this. So you in the question, what you will do in the place of s, you will just substitute 6 into re power j5 plus 1, and in all places of s you substitute this and put the r value as infinity. If you substitute and do, you will get 0 into e power minus j35. So angle is from minus 270 degree to 0 to plus 270 degree. 35. 3 into 180 means what? 8 3s are 27, 8 3s are 24. Sorry, it is not 180. It is 3 into 90. 90 means 90 into 3 means what? 270. So minus 270 to plus 270. Why? Because you got as 35. So if you see, it should be 270. 270 means approximately here. So the points look in this way and the Nyquist plot look in this way. If you see here, all the points are there. Minus 0 plus j0, minus 0 minus j0, and minus infinity minus j infinity, minus infinity plus j infinity. Okay. The point of intersection of Nyquistic plot on the real axis obtained by equating imaginary part. You can get this value, which point it is on the real axis. That is, the value what you got, the real axis is obtained to what? 0, equating the imaginary part to 0. Imaginary part if you put to 0, you will get omega equals to what? 1 by 3. In the same way, the value of j omega at omega equals to 1 by 3 is obtained by substituting the value of omega in the imaginary part, the real part of the j omega 1 This is the real part, this is the imaginary part. In the real part, if you substitute, what you will get, previously we already got this final value. Initially we substituted, no. In the same way, for the real part, if you substitute this, you will get what? 13 minus 13.5. For the imaginary point, if you do, you will get the value of omega, and if you put that omega value in the real part, you will get the value. So the Nyquist plot crosses the real axis at point 13.5. This is crossing the real part 13.5. Okay, at 1 by 3, at omega equals to 1 by 3. So based on the above information, an approximate Nyquist plot drawn for the Nyquist path shown in figure 8.12a is shown in figure. This is the Nyquist plot for this one. So we can tell from this plot, we can observe that the Nyquist plot of g of s into h of s encircles minus 1 plus j0. It is encircling minus 1 plus j0 pointwise on the clockwise direction. Therefore, n is what? Minus 2. Means the given open loop transfer function g of s, no poles in the right half of the s-plane. No poles on the right half of the s-plane. So p is what? 0. Thus 2 minus 2 is equals to 0. So z will be 0. 2 zeros are there. Hence 2 zeros in the right half of the s-plane. The closed loop system is unstable. The closed loop system is unstable. As minus 2 is equals to 0 means you will get z is equals to 2. So means 2 poles are on the right half of the s-plane. So the system is unstable. Okay. Why? Because here it is clockwise direction, 2 times it is encircling minus 1 plus j0. Means what? 2 zeros are present, minus 2. So it is present on the right half of the s-plane. So the system is unstable. To be stable, the pole should be left half of the s-plane. Fifth one, sketch the Nyquist plot and comment on the stability of the closed loop system whose open loop transfer function is this. Same like previously, what you will do, you will substitute s is equals to j omega, you will get some real part and imaginary part form. Then again omega equals to minus infinity, 0 minus, 0 plus, and plus infinity you will substitute, you will get some values. For these values, you will substitute in the place of s, r into e power j5, and limit r tends to infinity you will do. So you will get some value called 0 into e power minus j5. Means what? From 90 degree through 90 degree only. So from this you can draw the Nyquist plot for the given question. There are no poles at the origin, so there is no need to bypass. So if you see, you will get here 0 minus j omega, 0 plus j omega, it is pointed, minus k, 4k plus 4 j0 minus 4k minus j0. It is drawn. Okay. Then for finding k by 2 and omega equals to 3, at where the real axis is passing, we will see that. How it is that the map turns around from origin minus 90 through 0 to 90 degree as sketched in figure 8.14b. The point of intersection you need to find. How to find? The imaginary part what you have, that need to be equated to 0. You will get omega equals to plus or minus 3. So at 3, this 3 value again you should put in the real part of the equation what you got in initial. Then you will get the value called k by 2. K by 2. Okay. So at the point of omega equals to 3 at k by 2. Based on the above information, an approximate Nyquist plot is shown on the shown in figure. Examination of this plot reveals from k by 2 less than minus 1 or k greater than 1 by 4. That is for k less than minus 2 or k greater than 1 by 4. So if you see, if you consider here as k by 2, so the Nyquist plot is on the clockwise direction, and only once it is encircling this minus 1 plus j0 means there is 1 0 and no pole. Okay, so n is equals to p minus z, minus 1 equals to 0 minus z, z is equals to 1 means which is on the right half of the s-plane, and the system is unstable. The system is unstable. Okay. So this completes the Nyquist stability criterion and the sums related to that. in this video. I'm stopping the video here. In the next video, I will do this topic. By this, we complete the module 5 successfully and the subject also. So I'm stopping the video here. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.